Welcome to our last video for our geometry unit. This one is on surface area and nets of triangular prisms. So we've done a lot of rectangular ones. Now we're going to focus on the triangular prisms. Get your learning target, 6G4. This one's talking about the rectangles and triangles. And then our I can statement. I can use a net to calculate the surface area of a triangular prism.
All right. The surface area of the triangular prism is the sum of the areas of the two triangular bases and three rectangular faces. It's going to be a little different than the rectangular prisms that we've been talking about where the nets generally look the same and we had little decisions to be made. We're going to need to pay attention to what type of triangles we have in our triangular prisms, whether they're equilateral or right triangles. And then we need to make sure that we have 5 faces, 3 rectangles and 2 triangles when we were done. And then add them up for our surface area.
So the first one is already drawn for us. We've already laid out the net, but we need to find the surface area. And unfortunately, there's not a nice, neat, easy way all the time for triangular prisms. You just have to go find the surface area or the area of each of the separate pieces.
Can we label the words over here first to start us off?
Sure.
All right.
So here is the bottom.
Always starting with the bottom.
Left and right. And then this is going to be the back and the front.
All right.
So let's start with our bottom piece because that's what we always unfold from. It's a rectangle. It's got a base here of 12. The height is hiding over here, 20. So it's going to be 12 times 20, which is 240 centimeters squared. Then we can go over to the left-hand side.
That was the first one's easy with all of our rectangles being the same size.
We ease them into it. So this one is a 12 by 20 again. In most of the problems we do, this is not going to work out quite as nicely.
Don't take it for granted.
So don't assume all the rectangles are going to be the same here. And then our right is the same, 12 by 20.
We need to remember our formula. So a triangle is half of a parallelogram. So we've got a 12 by 10 divided by 2.
So that's the part you really got to watch for. The base here is easy, the 12. But you have to look for the measurement that it's at a right angle to the base, not just another side of the triangle, but at that right angle before we can use them. So we're going to do 12 times 10. But like Mrs. King said, it's a triangle, so we have to divide by 2. 12 times 10 is 120, divided by 2 is 60. The one part we can count on is both triangles in a triangular prism are going to be equal to each other. They're going to be mirror images to each other. So we know that the back is also going to be 60. And then we go ahead and add them together. 60 and 60 is 120. Plus 240 is 360. Plus another 240 gives me 600. Plus another 240 gives me 840. We're dealing with centimeters, so centimeters squared. It's still surface area, so the units are still going to be squared.
Good.
Next one.
Now we have to draw, which is going to be a little bit different because we have right triangles, more of a doorstop, block of cheese kind of wedge triangular prism. So we're going to start with our bottom. Our nets always start with our bottom. It's a rectangle. We need to make sure we know the dimensions. So he's going to use a rectangle, write the words bottom on it. Now he needs his dimensions. Looking at the figure, we have a height of 10 and the base of 12 yards.
So if one side is 12 and one side is 10, the 12 should be a little bit longer than the side that's 10. It should be drawn proportionally to our picture here.
Okay.
Now is where we have to get a little bit more creative. So I like to tack on my triangles first. So think of this edge here. And this is where you have to be careful. It's going to tip out in front with us. It shares this common edge of a 12. And then this vertical edge is a 5. So it shows our 12, and then it's going to kick out by 5. But notice it's not a rectangle, so it's going to come back like this for our triangle.
It's the longer side of the triangle called a hypotenuse. They think that word's funny.
Sure it is. And it's nice to put in that right angle so we can go back to that when we need it. But our front is 12 by 5. It unfolds. Now we're going to do the back side.
which flips out, and in this drawing kind of makes it look like a little airplane.
Sure, it's going to look like an airplane. But notice it's got the 12, but the same piece that's a 5
Has to go
matches up with the
parallel to
5
that
here.
5.
So it's going to unfold this way.
See, it does. It's going to.
Call that the back.
Get your 5 on there. Change color.
Now you may also want to include our other measurement for our triangle here. The slanted edge, Mrs. King called it the hypotenuse. It's the longest edge is 13. So we can also put our measurement of 13 on there.
Now that 13 should go conveniently right into that next.
So we're going to do the top or the side?
Well, I'm going to do the 13. Whoop.
All right, so the next piece we're going to do.
Did you get that? Whoop?
Yes, I got your little whoop.
Thank you. That's what I need. I need to like slide right down there.
So sometimes it's easier to shade these in just so you can kind of focus on it, but this is the top edge. It's going to unhinge and fold out this way. So it's going to unfold from our 10.
So the 10 stays parallel to the bottom.
And then our other measurement is our woot 13.
Yes, you slide from the airplane right down to the rectangle.
So apparently this is a sled right out of the... So this is, some people will call it the top, some people will call it the left side if it unfolds that way. But it had that base of 10, and then this slanted edge was 13. So notice how this 13 matches up with the 13 on our triangle. They're going to pair up with each other. What are you giggling about over there?
I thought you were going to say, forget it.
I was not going to say woot again.
We got 4 down, which means you got 1 left to do.
So here is, some people will call this the right-hand side, or some people just call it the side, but it's going to tip out this way.
Would I be wrong if I called it the back?
Yes, because we called this triangle the back already.
I know, but if I labeled that right and left, would you count it wrong? This is where we run into issues in class.
We'll discuss that in class. So it unhinges from the bottom, and it shares that common edge of 10. So here's our 10. And then it folds out to that height of 5. Think of this one kind of like our rectangular prisms. These corners match up with each other. And we're going to call this the right, or the side. Now,
we're ready to do our surface area.
We've just barely started. So now we have the bottom, the top, the right, and then I like to leave the front and the back of my triangles for the last piece.
Well, I was going to tackle those first. We are totally opposite. All right, our bottom triangle is a 10 by 12. So we write our multiplication sentence. 10 times 12 is equal to 120 yards squared. And then our top.
10 by 13.
We've got a 10 by 13, which gives us 130.
But this is why we make you write the measurements on each of the faces, so you don't have to go looking for those measurements later.
Our right-hand side is going to be a 10 by 5 to give us 50 yards squared. And now we're on triangles, which should remind us to divide by 2. So
look for the 2 measurements that meet at the right angle.
12.
5 by 12.
Again, ignoring that slant or that hypotenuse is not part of our triangles. So we end up with 30 yards squared for each of our triangles.
And that's the one area where you can count on them being the same measurement.
So those 2 together give us 60. Plus 50 is 110.
So these give us 110.
Oh, okay.
Up here we have 120 and 130 is 250. 250 plus 110 gives us 360.
Yards squared.
We're dealing in yards, so it's going to be yards squared. So you have to draw off the net, label everything with his name and his measurements, and then use that to go ahead and find your surface area.
All right.
Last one.
They had a tent drawn for you ready, but this time we are going to draw it ourselves. If you feel comfortable, go for it, and then check to see if you're right. But
so it should look similar to that very first example we did if you did this.
You need 3.
It's going to be a 2 meters by 9 meters.
Rectangles and 2 triangles when you're done.
She's going to sneeze on us here.
Yes, I am.
Everybody say bless you.
Okay.
So it's a 2 by 9, and that's the bottom. So always focus on where does it unfold, but trace it out, shade it in, whatever you need to be able to focus on that piece first.
Are going right and left now?
Yeah.
Okay. All right.
So now we're going to unfold this right-hand side. Yes, and they even make that cute little noise as they do it. It shares that edge of a 9.
9 by 2 as well. Like we said, don't get in the habit of
Assuming that they're going to be the same.
Yeah, the 9 by 2, but in this tent case it is. We label it right, and then he puts a congruent one on the left.
Congruent means the exact same shape and size, for those of you paying attention. So 2 by 9.
Left.
Because this triangle, all three sides of the triangle were all 2 meters, that's how we know all three sides are going to be the same size.
He's going to switch his colors, and the triangles would fold the opposite direction from the bottom. So he's going to go from the bottom, using that 2 for the base.
I know you call this a tent. I always think of it as a Toblerone, one of those little chocolates.
But you have to show them that. I showed, yeah.
So that's just going to kind of tip out from the bottom. It shares that common edge of 2. So it's going to share this piece here, but it's going to tip out like a point. Remember, if 2 is our base, our height is this vertical distance in here. So you should be drawing in that right angle symbol.
We should have 9 nowhere near, actually, these measurements, unless...
So that was our 1.7 meters there.
And that is your front, and he's going to draw another one in the back.
So I'm going to draw the matching one back here. So this is the back edge.
2.
But you need that right angle in there. So that's 2, and then our height is 1.7.
And then he's going to start our multiplication sentences.
Pretty sure I have no idea where our head is going to be in this problem.
Left, right, bottom.
So bottom, left,
front, back.
Right, and then our front and our back. Now the front and back are not going to be fun to calculate, sorry.
No, but the bottom,
we'll
left, and right is easy. 9 by 2 gives us 3 18s.
So since they're all the same, we can get those out of the way easily.
You can declare it. Or if you really want.
Not yet. Now we're going to focus on the front.
2 by 1.7.
Remember, look for that right angle.
Take the decimal out of it. 2 times 17 is 34.
But it's going to divide by 2. So if we want to save ourselves a little bit of work, it's a triangle. 2 divided by 2 is 1.
Right.
Times 1.7 is just 1.7. She was going to get there eventually, but I got there faster.
I was just going to combine them and call them 3.4 together.
I don't want them skipping the dividing part. That's an easy way of forgetting that one. So it's got a base of 2, a height of 1.7, but it's a triangle, so you always got to go back and divide by 2. So make your math easy. 2 divided by 2 is 1, times 1.7 is 1.7. Now we go ahead and we add them up. Mrs. King pointed out that these 3 together give us 54. These 2 give us 3.4. So altogether we get 57.4.
Meters.
Dealing in meters, so meters
squared.
All right.
Have a good night.
Have a good day. Enjoy your last geometry video.